Hello everyone, welcome to my channel. Today in this video we will be proving a theorem which is product of two subgroup is also a subgroup of G if and only if Hk equal to Kh. So first we'll consider that H and K are two subgroup. A group G. Now let us suppose that Hk is a subgroup. We have to prove that Hk equal to Kh. So now let's suppose x belongs to Hk. Then x inverse will also belongs to Hk. Since Hk is a subgroup, so it will also contain the inverse element. Now x belongs to Hk. It means that x will be equal to first element will be from H, which is H1, and second element will be from K, which is K1, belongs to Hk. For H1 belongs to H and K1 belongs to K. Now, since X belongs to Hk, we have, by using a theorem which is Hk is a subgroup, so Hk is also a group. So it will also contain inverse of all its element. So since we know that X is equal to H1 K1, then now we'll find the inverse element. If we inverse it, it will be H1 K1 inverse. We also know that it can be written as K1 inverse H1 inverse. It can be written in this way. So from here we can see that first element is from K and second element is from H. So from this condition and this condition we can see that X inverse belongs to Hk, and from this condition we can see that X inverse belongs to Kh. So we can see that Hk is a subset of Kh. Now we will have to prove that the opposite. So we'll consider y belongs to Kh, which will imply that y equal to K1 H1. So from here, if we take the inverse of this element, we can see that if we inverse it, it can be written as H1 inverse K1 inverse, which will belongs to Hk. Since we have assumed that Hk is a subgroup, so Hk also a group, so it will also contain the inverse of this element. The inverse of this element will be y. It will also contain the inverse of this element, which is y, So first we have supposed y belongs to kh, and we have come to the conclusion that y also belongs to hk. Therefore kh is a subset of hk. Now let's combine these two conditions, condition A and condition B. From A and B we can see that hk equal to kh. So in this way we have proven the first part. Now let's proceed to solving the second part. Conversely, here we have to suppose that hk equal to kh and h comma k are subgroup of G. Here we have to prove that hk is a subgroup of G. So now, first of all, we'll be considering an element. We'll be considering two elements. X comma y belongs to hk, which will imply that x equal to h1y1 h1k1 and y will be h2k2 for some h1 comma h2 belongs to h and k1 comma k2 belongs to k. So now in order to prove, I will be writing it here rough, it's rough work. In order to prove that hk is a subgroup, we have to show that if xy belongs to hk, then its inverse element, which is if xy belongs to hk, then xy inverse belongs to hk. So we have considered xy belongs to hk. Now let's see for xy inverse. So xy inverse, we'll write the element of x as and the element of y as h2k2 inverse. By following these steps, we can write h2k2 inverse as k2 inverse h2 inverse. Let's write what we have written in the previous page. Xy inverse, which was h1k1 k2 inverse h2 inverse. So we can also write it as this step. So now we'll be taking it, we'll be seeing this element k1 k2 inverse h2 inverse. As you can see here, see from here, k1 k2, it belongs to k, and h2 inverse belongs to h, which is kh. So we can also write it as K1 K2 inverse H2 inverse equal to H3 K3, since HK is equal to KH. Since this element is equal to KH, so it can also be written in the form of HK. So we have written it in the form H3 K3 for some H3 K3 belongs to some H3 belongs to H and K3 belongs to K. So since let's give this as equation 1 and this as equation 2. From 1 and 2 we'll be seeing that xy inverse will be equal to h1, and we'll be substituting the value here, which is h3 k3. Now let's use associative property. Now we can see that h1 h3 are elements of H, then k3 is element of K. Therefore we've come to the conclusion that hy inverse belongs to hk. Therefore hk is a subgroup. Thank you.